And because we had agreed that you will sort out the theory on your own, I will just go straight to question 2B. Question 2B. The following data relates to the weekly amount spent on entertainment by households. The annual income of the head of the household and the household size in terms of number of persons. So we have that. A computer output of the above data using a spreadsheet package was provided as follows. Regression statistics. Now we are given the ANOVA table and the table of coefficients. And then we are told to do the regression equation of the data, and we are told to route the figures to 2 decimal places. So in that case, the regression equation, we will have it this way. Regression equation. Regression equation. So the regression equation, the values are obtained from this table, the column that is titled coefficients. The column that is titled coefficients. So you will say y is equal to minus 4.1 plus 0.99x1 plus 1.76 x2 where y represents amount spent on entertainment, amount spent on entertainment. X1 is annual income. Annual income. X2 is household size. Household size is household size. Household size. Then from there, we are told to do a statistical analysis. We are told to do statistical analysis. Statistical analysis. Now the question is not clear exactly what should be done. The question is not clear exactly on what should be done. In that case, you do everything that is doable, or you do what you think should be done. For my case, I want to do everything that can be done using this data. Remember, when we talk about statistical analysis, it is about the reliability tests. It is about the reliability tests. Reliability tests. Reliability tests. It's about the reliability tests. So there are 3 types. The first one is called economic plausibility. Economic plausibility tests. Now, the economic plausibility tests Tutaipanga namna hii. We can have it like a table. We can have it like a table. Whereby we have independent variable, independent variable, expected this one I can have it like this. Relationship with dependent variable, relationship with dependent variable, and this relationship is divided into two. We have the expected and we have the observed, and then we will have the conclusion or the comments. The conclusion or the comments. So we have a table like that. Okay, you are saying you're not able to see clearly. Unfortunately, my camera cannot be adjusted. Let me change the mark pen. So this one is independent variable. Then relationship with dependent variable. This is expected, this is observed, and this is the conclusion. Conclusion. Okay. Let me change the mark pen. So the first independent variable is annual income. Annual income. And the second one is household size. Household size. Is that visible now? Aika and Beth, are you able to see that now? Okay. So what? So the expected relationship between annual income and our dependent variable, which is the amount spent, we expect a direct relationship. And even the household, we also expect a direct relationship. Remember, a direct relationship is where so just copy from where you can see Haika. Maybe I'll take a photo and send that bit. I'll take a photo and send that bit. I'm saying the relationship is direct. The relationship is direct. So what have we observed? We have observed a direct relationship. This one is also direct. That is positive 0.99. That's a direct relationship. Then here we have also observed a direct relationship. That is 1.76, which is positive. So what do we conclude? This one is plausible because they are in agreement. And this one is also plausible. It is said to be plausible. It is said to be plausible if what you expected is in agreement with what you have observed. It is in agreement with what you have observed. Aika, now it should be sorted. Check the group. Okay, so we proceed. The next group of tests, B is called goodness of fit tests. Now, the goodness of fit tests, there are 6 of them. So you go checking whether each has been mentioned. One is R square. So R square, I could still give you the coefficient of determination. That is R square. Coefficient of determination, R square. Now, if you look at this question, you can see R square, it is 0.45. So that one, if you express it as a percent, you say R square is 45%, meaning 45% of amount spent depends on, or is explained, depends on income and size, income and family size, or household size. So 45% of the amount spent, it depends on the annual income and family size. And something else that you could comment about that, it shows it is therefore a very weak relationship. That should be rejected. A very weak relationship that should be rejected. Remember, if a relationship is below 60%, you are supposed to reject it. if it is below 60%. The next thing that we need to talk about, is about number 2, what we call standard error of estimate. Standard error of estimate. Standard error of estimate. Standard error of estimate, SE. Standard error of estimate, SE. Now this one is not provided. Is not provided. So if it is not provided, you don't comment about it. You don't comment about it because it is not provided in the question. Number 3, it is what we call F-tests. Now F-tests, it is provided. We are given F calculated from your table. The table of ANOVA, you can see where it's written F. So F calculated is 6.89. I hope you're able to see that figure, 6.89. Then F critical is the one that is given there as significant. So to 2 decimals, that is 0.01. That is 0.01. And therefore, we comment conclusion that you make is that the relationship is significant. The relationship is significant since F calculated is greater than F critical. That is 6.89 is greater than 0.01. 6.89 is greater than. Is greater than. So F has been provided. F has been provided. Number 4, the next test, number 4, is correlation coefficient. Correlation coefficient. R. Correlation coefficient R. Now the correlation coefficient R, as you can see in the table, what is written as multiple R, you say R is 0.67. R is 0.67. After giving us the value, you need to tell us the meaning. It shows a strong direct relationship. A strong direct relationship. You cannot say it is very strong because it is not very close to 1. It's not very close to 1, but it's not badly off. 0.67 is a good measure. Is a good measure. The next thing, number 5, is standard error. Standard error of the slope. Standard error of the slope, that is SB. standard error of the slope. Standard error of the slope. So for the annual income, for the X1, SB is equal to, you go to the table where you can see the standard errors. The last table where you can see the standard errors, it is 0.31. 0.31. And then for X2, SB is 1.72. 1.72. If you go to the table where you can see the errors, 1.72. Now, what did we say about the standard errors? If you check your notes, we say the smaller the error, the better the equation. So we are going to say that X1 is better. X1 is better than X2 since it has a smaller error. It has a smaller error. So X1 is better. Income seems to explain the expenditure better than how household is explaining. Yeah, that is how we go about it. The next test, number 6, we normally call it t-test. It is t-test. It is t-test. Now, t-tests, we will arrange it like this. We will arrange it like this. We have the independent. We have the independent variable. We have independent variable. Independent variable. We have t calculated. We have plus or minus t critical. And we have the conclusion or the comment. We have the conclusion or the comment. Conclusion or the comment. We have the conclusion or the comment. Now for the independent variables, you can either use the representatives x1 and x2, because we already have said in our workings, x1 represents what and x2 represents what. Or alternatively, you can write the full names. Alternatively, you can write the full names, whichever pleases you. Okay. Now the t calculated, if you go again to the table, the last table, you will see a column that is titled T statistic. T statistic. So if you are there, those are the T calculated values. So for the income, it is 3.14. 3.14. And for this other one, it is 1.03. It is 1.03. Then the value that is given there as p value, the second column or in the next column, p-value are what we call the critical, the values that we read from the tables. So that one will be 0, so it will plus or minus 0.01. And this other one is plus or minus 0.32. Plus or minus 0.32. Now, maybe I remind you on how these comments are made. If you look at the decision rule that we normally draw, it is usually divided into two. It's usually divided into two. I can even divide it easily. This is where we have minus T critical. And this is where we have positive T critical. If your value is anywhere here, we say it is insignificant. 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 I want to use the short form. And if you are below here, we say it is significant. If you are above here, we say it is significant. We say it is significant. So I'll write you now to tell me whether X1 is significant or insignificant. If this is minus 0.01, this is plus 0.01, and the calculated is 3.14. And you tell me whether X1 is significant or insignificant. I'm waiting, Beth, Eva, Aika, and Timothy. I want to hear from you. Is that significant or insignificant? Yeah. Aika says it is insignificant. Okay, this one, Aika, is very significant. And why it is significant is because you can see, this one is supposed to be minus 0.01. And this is positive 0.01. This one. So if you come looking for 3.1, 3 iko na huku. And when you are above here, we say it is significant. Is that okay, Haika? Okay, what about the other one? What about X2? Is it significant or insignificant? Yes, Beth, you say it is significant. Good. This one is significant. Because you can see this 1.3, it is on the upper side. If this is 0.32, it is on the upper side. Yes, Eva, good. So I think we are okay with that. That was the second set of tests. Now we go to number 3. We go to number 3, which is called assumptions. That is C. We call them assumptions. We call them assumptions. Once again, there are 6 assumptions. There are 6 assumptions. Number 1 is called linearity. It's called linearity. Now, linearity, you simply check whether this equation takes the general form of a linear function. So you will say the relationship is linear. The relationship is linear since the equation obtains has taken the shape, has taken the general form, the general format of y is equals to a plus bx. The relationship is linear since the equation obtained has taken the general format of y is equals to a plus bx. So you can see this equation that we got here, it took that format. So the relationship is linear. The relationship is linear. The second assumption is called zero mean. Zero mean. The zero mean of the error terms. Now, this question has not given us data for the errors, so we cannot test that. Number 3, it is called constant variance. Constant variance. Number 3 is called constant variance. Number 4 is called normality. It's called normality. Number 5 is called autocorrelation. Autocorrelation. And number 6 is called multicollinearity. Multicollinearity. So all these, they are not provided in the question at hand. And as I said earlier, if something is not provided, you don't discuss it, you don't talk about it. But for me, I've chosen to mention that so that you can be able to get time after this lesson and look at what all this means and how they are tested. So that is a good recap of what we call reliability tests. And that is exactly what we had done the other day in our handout when we revised the question of June 2005, question 1. So at that point, I'm confident that if you came across a question on ANOVA, you will be able to handle it confidently and accurately. So if you are okay, type okay so that I proceed to the next question. If you are not okay, you register your concern by writing. Yeah, Beth is okay. The others? Eva is also okay. Aika is saying I move. Timothy, are you okay? Okay, there's Aika. Timothy, I hope you are still in class. So look at question 3C. Question 3C of May 2018. 3C. Question 3C. May 2018. Question 3C. Now you have seen it. You have seen it is inventory controls. Inventory controls and simulation. Inventory controls and simulation. So as usual, when you see inventory controls, rather simulation, we begin by doing the Monte Carlos. So we are going to say Monte Carlo for demand. Monte Carlo for demand, whereby we begin with units, then we have probability, then we have cumulative probability, and then we have the range. So the demands are running from 3. We have 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 11 and 12. Then I also create space for Monte Carlo for read time. Monte Carlo for read time. So here, this read time is in days. And these days are 2, 3, 4, 5. 2, 3, 4, 5. Then I have probability, cumulative probability, and the range. And the range. So the probabilities for these ones are 0.02, 0.08, 0.11, 0.16, 0.19, 0.13, 0.10, 0.08, 0.07, and 0.06. So accumulating, this will be 0.02, this will be 0.10, 0.21, 0.37, 0.56, 0.69, 0.79, 0.87, 0.94, and 1. I believe we are all comfortable with how to create the range, but if you are not, you should let me know. So this is 00 to 01, 02 to 09, 10 to 20, 21 to 36, 37 to 55, then 56 to 68, 69 to 78, 79 to 86, 87 to 93, 94 to 99. This is 0.20, 0.30, 0.35, and 0.15, 0.20, 0.50, 0.85, and 1. So this is 00 to 19, 20 to 49, 50 to 84, 85 to 99. So I want us to design the simulation sheet, which is also known as the logic. It's also known as the logic. So we are told to run for 10 days. So we will say day number. We have day number there. Then we always have the opening stock. Opening stock. Then it is closely followed by demand. Demand, we have the random number, and then we have the units, the random number and the units. That is followed by units sold, units sold. It is followed by shortage units, shortage units. It is followed by closing stock. It's followed by closing stock. Closing stock. It is followed by order. Not I had a big space to draination. It is followed by lead time. We have random number and days. Make my space require working. Let me design it again so that I don't. Let me design, but nothing is changing. Nothing is changing. It's only that I need some bigger space. I have total here. That should be the very last column. I have ordering. Ordering. have shortage, and I have holding. So these are the costs. Then I have days here and random number. So this is lead time. Then order here. Then closing stock. Shortage. Shortage units. Shortage units. Units sold. Units sold. I have units here. A random number. This is demand. This is opening stock. Then I have day number. So this is my simulation sheet or the logic. Simulation sheets or the logic. So if you are finished drawing, Andika finished. We are finished drawing, Andika finished. Yeah, I can see already Eva has finished. So the others. Okay, let me proceed. For the mud, we can actually even write them like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we require total and the average. Total and the average. I've given more space. Total and the average. So let's first of all put the random numbers for demand. This is 68. This is 13. This is 09. Then I have 20, followed by 73, followed by 07, followed by 92, 99, 93, and 18. However, for the read time, you only put the random numbers when there is need. You only put the random numbers when you need to place an order. So you don't put them like we have done here. So, nikiweka units, 68 iko hapa, those are 8 units. 13 iko hapa, those are 5 units. 09 is here, this is what? 4 units. 20 is here, this is 5. 73, iko hapa, 9 units. 07, 4 units. 92, 11. 99, 12. 93, 11. 18 is 5. 18 is 5. So remember, there are different approaches of dealing with this. One is kujaza the random numbers for the mad unamaliza, like what you have done. The second one is where you go at a time, a day at a time. So unachukua day 1, unaenda mpaka huko mwisho unamaliza. So all of them are acceptable. All of them are acceptable. So let's begin the analysis. Beginning the analysis, you will notice, you will get to notice that the opening stock, according to information 3, is 30 units. The opening stock is 30 units, so you put 30 here. And then we are told the reorder quantity is 40 and the reorder level is 20. So we begin. You have opening stock of 30, demand is 8, so you sell all the 8 because you can afford, and no one goes home without. And therefore the closing stock is 22. And do you place the order? No, because you have not gone below 20. Then when you say no, there is nothing in the lead time. There is nothing in the lead time. Now for the holding cost, according to information 2, the holding cost is 2 shillings per unit. So utasema 22 times 2, that is 44 The shortage is 0, ordering is 0, and therefore here we have 44 commission. Day number 2, we open with 22. The closing stock there becomes the opening stock here. We get 5 customers coming, so we are able to sell to all of them because we have more than 5. So no one goes home without what they wanted, and we close the day with 17. Now we are below 20, the reorder point. But you don't make the order at that point, so you still say no. Reason being, it is after you have closed your business that you come to realize you are closing stock. So if already you have closed, you don't place orders at night. Those people who supply you, they already have also closed. And even the other departments in your company, they have also closed. So tomorrow morning, that is when you shall place the order. So meanwhile, we proceed, and having said no, there is nothing there in the lead time. So for the holding cost, it is 2 times 17, which is that 4, and no shortage, no ordering, and we have that 4. We have that 4. From there, day 3, we open with 17. We sell 4 units. Here, because that is the number of customers who come. Shortage is 0, no one misses. So we close with 13. Do you place the order? Yes. This is the time we are closing, we are placing the order. So when you say yes, you pick the first random number of read time, which is 30. Which is 30. Then with that 30, you go to the Monte Carlo of read time. And when you come here, unapata 30 iko hapa, where we have 3 days. So you tell us these are 3 days that week. Then from there, you need to count 3 days from there, including the day of the order. So tunahesabiwa hivi 1, 2, 3. So those 3 days must lapse. So the order that we are placing on day 3 will be received on day 6. You can even mark it that way. The order that we are placing on day 3 will be received on day 6 in the morning. Meanwhile, as we wait for that order, we proceed with the analysis. So holding cost would be 13 times 2, that is 26. No one has missed, but the cost of placing an order, which we have done this morning, according to information 1, is 8 shillings. So this is 8 here, and when you add, that gives you 106. When you add, that gives you 106. We go to number 4. We are now opening with 13. Demand is 5. So you sell all the 5. No one goes home without. And you close with 8. Place the order? No, because we are just waiting the other one that we placed. So when you say no, nothing here. The holding cost is 8 times 2, which is 16. Shortage 0. Ordering 0. So the cost is 16. The cost is 16. We go to number 5, where we are opening with 8 units. 9 customers come. When 9 customers come, we sell 8 because those are the units we have. Therefore, one customer goes home without. One customer goes home without, and we close with 0. And then we are not placing an order, so nothing here. So if we have closed with 0, the holding cost is 0. Shortage cost now, according to information number what? Number 2, every unit out of stock is costing 20 bob. So that will be 20 shillings here. And then this is 0, and this is 20 here. Then from there, day 6 we are opening with 0, but it's also the day we are receiving. So you say 0 plus. We are receiving our order of 40 units. 40 units. I'm putting that 0 there because it's not all the times when you'll be receiving the order, you will be at 0. There are times you'll be having some few units. So you add them to the new arrivals. So 4 customers come. When 4 customers come, we sell 4 units. We sell 4 units. And then no one will miss. So the closing stock is that 6 units. We place the order? No. And then the lead time is 0. Sorry, nothing there. So the holding cost will be 2 times that 6 times 72. No shortage costs, no ordering costs, and this is 72. 72. So 36 is the opening stock. 11 customers come, so we are able to sell all the 11, and no one goes home without. So tunafunga hiyo siku with 25 units, and then you place the order? No. So nothing here. And the holding cost will be 25 times 2, which is 50. Then the shortage 0, the ordering 0. So we have 50 there. 50. Then for number 8, we open with 25. 12 customers come, so we are able to sell 12. Shortage units, no one lacks. So we close with 13 units. So we are already below our order point of 20, but as I said, we are placing the order the following day. So you say no, and there is nothing there now. So the holding cost is 13 times 2, which is 26. And no shortage, no ordering, and we have 26 there. We have 26. Then day 9, we open with 13 units. We open with 13, where we now have a unit sold being 11. No one misses. No one misses. And the closing stock is 2 units. And it is the time to place the order. It's the time to place the order. So we say yes. So take the second random number, which is 22. So 22, ukikibia nayo hapa kwa Monte Carlo, you find again it is 3 days. So when it gives you 3 days, those must be day 9, 10, 11. So those goods will be received on day 12, which is not part of our analysis. It's not part of our analysis period. So that one we leave it and proceed. So the holding cost will be 2 times 2, that is 4 shillings. No shortage, but we have ordering of 80, and this gives us 84. That gives us 84. The next is day 10, when we are opening with 2 units. 5 customers come, and that means we are only able to sell 2, report a shortage of 3, close the business with 0. You don't place the order, so nothing here. So no holding cost, but we have a shortage cost of 20 times 3. That is 60. No ordering, and this is 60. So from there now you say 60 plus 84 plus 26 plus 50 plus 72 plus 20 plus 16 plus 106 plus 34 plus 44 is 512. 512, that is the total. 512, that is the total. And then the average should be 51.2. The average should be 51.2. The average should be 1.2. So are we okay with that? So I think because of the interest of time, time is already, I'm only having 7 minutes. I cannot be able to start and finish the next question. So we stop there for now. I said I'm going to send you 2 videos that will complete what was supposed to be covered in the handout I had given you, hoping that you have been watching the others. Hoping that you have been watching the others. So if you have been watching the others, then you realize where I have picked today, that is where we are. So watch the others. I will send you 2 more so that you are able to see everything. So thank you so much. Have a good day, and we meet now on Monday, God willing.